Hey guys, today we are going to be talking about potential energy and kinetic energy. We are going to be identifying and comparing the differences between potential energy and kinetic energy. And by doing that, we're going to be looking at real world examples. Like right here, if you were to jump off a pier, per se, you would have potential energy while you're standing on the pier. And as you jump and you start to move, that potential energy is then converted into kinetic energy as you begin to go into motion. And we're going to go over this more. One more example before we get started is this little boy who's holding a bow and arrow. When he has it cocked back completely and not in motion, he has stored up potential energy. When he goes to release it, that potential energy is going to be converted into kinetic energy. And here is the CPALM's standards and objectives that we will be going over. So first and foremost, all energy. All energy can be broken into two main groups. You have your potential energy and your kinetic energy. And then your potential energy can be subdivided into three more groups known as gravitational energy, kind of like that jumping off the pier or a rock falling, chemical energy, batteries, stuff like that. And then elastic energy, say you're jumping on a trampoline and there's springs involved. So I want to take a moment and watch this little video to go more into depth about how it works and what we're going to be looking at.
Oh, you have a lot of energy. Do you know what is energy? Yes, you are right. Energy is the ability to do work. Okay, there are many sources of energy. For example, sun, wind, water, etc. And yes, energy also comes from your muscles. Let me tell you a secret. Do you know energy cannot be created or destroyed? It can only be stored or transferred. Oh, you look confused. Let me explain it further. All energy in this world exists in two forms. One is called potential energy and the other is called kinetic energy. Remember, potential energy is stored energy in the object, whereas kinetic energy is energy of motion. Let's see a few examples of potential energy. Have you seen a catapult? It has so much stored energy that it can throw stones to distant places. Also, look at this big rock on the slope. If it falls down, it can do a lot of damage. It has a lot of potential energy, which means a lot of stored energy. There are three types of potential energy. Let's look at each type. See, this stone on the top of the mountain has gravitational potential energy. This is also called potential energy of an object due to its position. Now look at this. This is due to stored energy of the spring. This is a battery. This contains chemical potential energy. It can light a bulb. Now let's look at kinetic energy. See this? The stone is falling down. Now it has kinetic energy. The potential energy has changed into kinetic energy. Now look at this pendulum. It shows clear example of potential and kinetic energy. If you hold the pendulum on one side, it has potential energy. But as you release it, the potential energy gets converted to kinetic energy. So stored energy and motion energy. It is stored energy and motion energy. So now you understand energy. Good then, keep dancing. Remember, potential energy is stored energy in the object, whereas kinetic energy is energy of motion. Look at this big rock on the slope. If it falls down, it can do a lot of damage. It has a lot of potential energy, which means a lot of stored energy. Now let's look at kinetic energy. See this? The stone is falling down. Now it has kinetic energy. The potential energy has changed into kinetic energy. Now you're going.
All right, so that video I wanted to show you to get a better grasp and a better understanding of the differences between kinetic energy and potential energy. The next thing I want to look at is examples, real life examples that you'll see in your everyday life that you could come across, and it'll have potential or kinetic. So let's think. I want to go over these, give you a few minutes to make a decision, and then we'll go over them together. So the first one is this battery right here. Do you think it has kinetic energy or potential energy? If you said potential energy, you'd be correct. Why? The battery is sitting there. It has potential energy within it because it's not doing nothing. It's sitting there. It's stored up. Let's look at this one. This is a battery that's lighting up a light bulb. Oops. This is a battery that's lighting up a light bulb. So do you think this is potential energy or kinetic energy? Take a second, think about it. If you said kinetic energy, you'd be correct. Why? Well, if you looked at our example of just the battery sitting alone, not powering anything, that was potential energy because it was stored within the battery. Now we've taken our battery, we've hooked it up through wires, and we're actually creating an electrical circuit where it's moving through the battery into the light bulb, back through the other wire, down to the battery, and it makes like a circle. So it's moving. If you look at this guy right here, he's running. Do you think that is potential energy or kinetic energy? If you said kinetic energy, you'd be correct. Why? He's running. He is in motion. Kinetic is motion. And then for this final one, you have a rock on a hill. Do you think it's potential or kinetic? If you said potential energy, you'd be correct. Why? The rock is sitting at the top of the hill. It has stored energy. Once the rock moves down the hill, or if it gets rolled off the hill, that potential energy will be converted into kinetic energy. So a couple of misconceptions that students may think or you may find. The first one is that kinetic energy is made by the momentum of the object. That's not true. Just because an object is moving and is accelerating, that does not cause the kinetic energy. The energy has always been there. You cannot create nor destroy energy. So the correct thinking for this is that when the object starts moving from its original position when it had potential energy, that potential energy is being converted into that kinetic energy. It's not creating more energy. It was already there. The second misconception is that potential energy is transferred to kinetic energy and that potential energy no longer exists, or that the potential energy is destroyed. That's inaccurate. Why? Because let's say there's a pendulum swinging, like that example in the video we watched. Well, when that pendulum comes back up to an area of resting point, it now has potential energy again. And then that potential energy, when it starts to swing, is converted to kinetic, goes back up, stopping point, potential energy again. It's never destroyed. It's always there. It's just transformed or made into the opposite energy. And here's a little picture of Albert Einstein. States energy cannot be created or destroyed. It can only be changed from one form to another.